All right, welcome back. This is pretty much a continuation of day 4 because now instead of, expanding, we're going to condensing. We're going to make things smaller. So if I wanted to evaluate this, how could we break this apart? Okay, so what is 0.001? Okay, well, right now I have log 10 of 0.001, which is 10 to the negative 4th. Okay. So again, I wanted to make it have the base be 10, so then these can cancel out. Then I have plus 2L, natural log E, well, that can cancel, minus 7 natural log E, plus log of 1. So we're going to see what can we cancel out and go from there. So this cancels out, so then I have negative 4. These two cancel out, so I have plus 2. These cancel out, I have minus 7. And then if I have the log of 1, well, log of 1 means 0. Okay, so now I just have negative 4 plus 2 minus 7 plus 0, which equals, so I've got negative 2 minus 7, which we've got negative 9. Awesome. All right, now let's remind ourselves, log of A times B, well, that means that it's adding, so log A plus log B. It's good on our notes to have just the basic information written down so then we know what we can reference back to. Sometimes when we just have examples, we go, what? Where did this come from? And then for this one, put the exponent in front of the log. All right, so describe the domain and range of natural log x plus 4. Well, what does that 4 tell me? Okay, so let's remind ourselves, what is the opposite of this problem? Well, that would be e to the x, right? And if I had e to the x, well, that would be e to the, so if I was finding the domain for e to the x, right, so if we were doing an exponential, we would have domain as all real numbers, and the range would be y is greater than 0. So when we're handling this type of problem, okay, that is the opposite. So you're going to switch the domain and range. So the range is going to be all real numbers. The range is all real numbers. And then the domain is x is greater than 0. Okay. So again, so instead of our graph going up like this, okay, we're doing the opposite. We are, flipping the numbers, and then that would be our natural log. Okay. All right, use properties of logarithms to condense each logarithmic expression. So log 11 plus log 15. So we are condensing now. So instead of plus, I'm going to multiply. So log 11 times 15, we're going to multiply those together, and I get log of 165. Okay, now what if it's a subtraction problem? Well, that means I have division. So 24 divided by 2, do the actual work. And 24 divided by 2 would be 12. All right, moving right along. This is one factor, so I cannot separate that, okay? So I have log of 3x plus 9 over x, okay? Now, a lot of people are like, oh, I can cross out those x's. I can't because this is one thing. If there was a 3 on the bottom, then I could do, I could take out the greatest common factor and reduce from there. But in this situation, I can't make it any smaller. Again, if this is one factor, we can't break it apart. All right, so let's look at 4, 5, and 6. So I want you to look at these and see, okay, how would I go backwards? So then the 1/2 would go back up here. So I would have ln x to the 1/2. Okay, and then it says plus. Well, that means multiplying times the y. So that's how I could make it smaller, okay? Well, I can make it actually even smaller than that because x to the 1/2 means square root. So I could do ln the square root of x times y. If that looks funky to you, you can, again, flip it because multiplying, you can do one or the other. So either one is fine. All right, for the next one, this 2 becomes an exponent. This 4 becomes an exponent, okay? So then I have log b x squared p to the 4th, okay, because I multiply them together. All right, if all of these are added together, then I'm just going to put all the letters multiplied together. So log R-I-T-E. Perfect. All right, try out 7 and 8. A little bit more complicated, but look to see what are we, the numbers in front become exponents. Okay, and then focusing on whether it's plus or minus to determine if you're multiplying or dividing them. All right, so that's what we've got for number 7. When it is x plus 7, that is one factor. So you keep that together, and then that whole thing is to the 4th power. Let me change the color so you know what I mean. So this 4 and this x plus 7, this whole thing is to the 4th power because it's in parentheses. So let's look at that for number 8. So if I have log of 5 to the x plus the w, that means that they're multiplied, and then it says to the 1/3. So that means this whole thing is to the 1/3. So I'm actually going to cube root it. Okay? And then it says subtraction of this. Y plus 2 is one factor. So then this whole thing is going to be over y plus 2. All right? So that's the answer for number 8. All right, move right along to number 9. And number 10. All right, so for number 9, we've got 1/2 times, and then we have this whole thing. So if you notice, the 1/2 is to the whole enchilada, okay? So I'm actually going to put the whole thing in this radical. Then I have x plus 7, and then it says minus x, and then it says minus y, okay? So if it's minus, that means they have to go on the bottom. Okay, and then that whole thing in the radical. Now, can I cross out these x's? They're both under the radical. No, we cannot. So I need you to think about this. X plus 7 is one thing, okay? It is one factor, so we can't break it apart. All right, let's move on to number 10. Work that out and check back. All right, so if they're plus, they go on the top. So this one's a positive and this one's a plus. So those two go on the top. And then I have the minus log 17 minus log x plus 4. Those go on the bottom. Okay, from here I notice, okay, these are multiplied together. So this I actually can factor. Okay, this is the difference of two squares. So I have x plus 4 and x minus 4, and then I have this over 17 times x plus 4. So x and 17, no, I can't take anything out, but these x plus 4s, I can actually cancel those out. So then my remaining answer is log, there's nothing, okay, so we got log x times x minus 4 over 17. And that would be my final answer. All right, now let's go to change of base formula. So if I have log b of x, that's going to equal log a of x over log a of b. All right, guys, so just cancel this out. So then this is what I have as our final answer. So I'm breaking apart, the x goes on top, the b goes on bottom, and then they have the same base. Okay? All right, so let's try this for number 11. So it says use the change of base formula, and then I'm going to evaluate using 3 decimal places. So again, that would be the 1,000th. Okay, so I'm going to break it apart, log 17 over log of 4. So make sure you guys are actually plugging this into your calculator. So then I would have 2.044. Okay, now let's try the next one. So I have log of 317 over log of 3. Try that into your calculator and see what you get. All right, so looking at number 12, when we break it apart, I want you guys to be careful when you're plugging it into your graphing calculator. So the first one, it says log of 317 divided by 3. So this is all one unit. What I need is I need them to be separate. So log of 317 divided by log of 3. So this is how you need to write it. Log of 317 divided by log of 3. Okay, then we're going to go to the 3rd decimal place, so that's the 1,000th. So I'm going to round up, so 5.242. All right, so make sure you have those answers for number 11 and for number 12. Okay? All right, now it says use the change of base formula to solve the following exponential equations. Get a common base. So what is 144? Well, that's 12 to the what? We need to change that to 12 to the second. And then what happens? Well, the bases are the same. Ta-da! So they can cancel each other out, and you get x equals 2. Okay? So what we're doing is we are trying to make the bases the same, therefore then the exponents equal each other. Now 7x and 18, I can't do 7 to the something to get 18. That's not going to happen. So what you're going to do is you're going to put log, you're going to plug in log on each side. So log of 7 to the x equals log of 18. So I'm inputting in log when you cannot get a common base. So this is what we do. This is what's up. Okay, now I need to bring the x in the front. So x log of 7 equals log of 18. Now, how do I isolate this x? Well, these are multiplied together. So what's the opposite? Dividing. And then we're going to do what we did on number 11 and number 12. We are going to divide this and see what you get as your answer. And now we can plug it into the calculator. Okay, so we're going to find that log button. Log of 18, 1/8, okay, divided by log of 7, and then enter. And then again, round to the thousandth, so 1.485. There we go. Okay. All right. Now we're getting a little bit more complicated, but we're almost there, guys. So change of base formula. So if I get 14, 2 to the x equals 21. All right. So let's think about what we can do for both of these. All right. Well, again, I don't think we can come up with a common base, right? So like 14 and 21, there's nothing that 2 to the something, I can't get 14. 3 to the something, I can't get either the 14 or the 21. So again, if you can't find a common base, you put a log in there. So log of 14, 2 to the x equals log of 21. Okay, and then I'm going to bring this exponent into the front, and I have 2x log 14 equals log 21. Okay, what are we doing? We're trying to isolate the variable. Okay, so if all of this is multiplied together, what I can do is I can extract and take out the 2 log 14. And I can actually take all of that out to both sides. Okay, and now I have x equals what? So plug that into your calculator. Make sure you get the answer of 0.577. All righty. Okay, one more problem. Here we go. Which of the following sets of equations are not inverses of each other? Okay, so we got to look at the differences between these problems. So I'm trying to look at patterns and see what's going on. So when x minus 1 is in there, what does that actually mean, right? Compared to when it's x plus 7. Do you guys see how one is, the parentheses is on the inside, and one, the number is on the outside, okay? So when the parentheses is on the inside, okay, well, what's the opposite of minus 1? Well, that would be plus 1. So what's happening is the h, right, is changing to the k, right? This is the h because it's on the inside of the parentheses, and it's changing to the outside, which is the k. The same thing with this one. The k is changing to the h. So the plus 7 is now becoming minus 7 as the h, because the h is in the exponent. If we remember that in our equation, right? So we had b times x minus h plus k. That was when we were doing exponential. Anyone out there? Yep. All right, so this is my k. And did it change to my h in this situation? No, it didn't. It stayed as the k because it's outside the parentheses. So this would not be an inverse. The rest of them are. See, this 2 is the h, and it's changing to the k. The sign is changing, and then we're flipping it from, the h to the k or k to the h. All right. So if you have any questions on this, please ask your teacher. And thanks so much for joining me on day 5.